Hello and welcome, dear students. So we have exercise 2.2, question number 1, bit 5, t square minus 15. Again, first thing we have to find the zeros or factorize. And the second thing that we have to do is we have to verify the relationship between coefficients and zeros. So now in this question, we can see the question is t square minus 15. It again has two terms. We know that a standard quadratic polynomial has three terms as ax square plus bx plus c. That means a square variable term and a linear variable term and a constant. Now in this question, there are only two terms. So that means the middle term, the linear variable term is not present. The first term and the last term are present. That is ax square and c are present. The middle term is not there. So definitely we cannot split the middle term. We cannot factorize it in the normal quadratic factorization method by splitting the middle term, because there is no middle term actually in this question. So we'll try to utilize some other format or some other identities that we have learned. So we will see that the other identity that we can use here, that starts with a square with a square term, is a square minus b square. So we can directly write the factors as a plus b, a minus b. So this is an important identity, and we see that our given polynomial expression is of this format. So we'll try to apply this identity straight away, but we need to know what should be our a and what should be our b. So what should we put in place of first term to get t square, and what should we put in place of the second term to get 15? So we see that t square will give us t square, but to get 15 we should have root of 15. Square root of 15, when we square it, it will give us 15. So our a here for factorization, the a will be t and the b will be root of 15. So now we'll apply this identity here and we will write t square minus under root of 15 square. And now after writing in this form, we are already easily find the factors, that is t plus root 15 and t minus root 15. So these are the factors of our polynomial, and once we have the factors, that means we can straight away get the zeros. As we already know, zeros are the values of t which, if we apply to the given polynomial, the entire value of the polynomial will become equal to 0. So considering this, either the first factor should be 0 or the second factor should be 0. So either t plus root 15 should be equal to 0, or t minus root 15 should be equal to 0. Now simplifying this, we get t is equal to minus root of 15 or t is equal to plus root of 15. So we get our zeros here. The zeros are minus root 15 and plus root 15, or simply root of 15. So now here we can easily find the sum. So sum of zeros will be minus root 15 plus root 15. Now you can see that both the values are equal, so we get 0. When the same values are subtracted, then we get 0. Now the product will be minus root 15 multiplied by plus root 15. Now root 15 into root 15, we have already seen here that when we multiply it 2 times, the root is removed and we get 15, and the minus sign, there is a single minus sign, so the minus sign will be applied. So the sum is 0 and the product is minus 15. Now we will also find the sum and product using coefficients. Now here in this case, we had already seen that this is not in the standard form. So we'll try to put it in the standard form, and we'll write it as t square plus minus 15 plus 0t. So now we can note down the a. A is the coefficient of t square, that is 1. B is the coefficient of the middle term, that is 0, and C is the coefficient, C is the last constant term, that is minus 15. So now using the coefficients we can find the sum. The sum will be minus b upon a, that is equal to 0 minus 0 upon 1. So that equals to 0. And the product will be equal to similarly c upon a, so that will be equal to minus 15 upon 1. So the product is equal to minus 15. Now we can compare the sum and product that we have found on both the sides using the zeros. The sum was 0 and the product was minus 15, and using coefficients also it's the same, we get the same answer. So since we see the relationship between zeros and coefficient, and hence it is verified.